Hi everyone. Today we are going to discuss about mastering the game of Go with deep neural networks and research, and mastering the game of Go without human knowledge. And this is Chartashri, and my teammates are Rajesh Kale and Rajesh Tamarvarpu. And I'm going to discuss about game of Go, and these are our contents. Next slide, please. Game of Go. These game Go has been evaluated by computing all the possible optimal value functions. AlphaGo becomes the number one game that differs the world champion. It always one game that differs the world champion. In this network are always integrated with MCTS, and deep neural networks are selected as the next moves to analyze the position of Monte Carlo research. In this, human expertise performance is very low. It began to work as an expert, as an human player. Next slide, please. Monte Carlo search can estimate the future state in research by estimating all possible solutions that it can execute. As the research increases size, um, it can execute the possible and relevant values and can be developed up to a level accuracy that the game can perform. And here we can see that uh, Go game that helped in developing the accuracy rate, achieving the 98% accuracy rate. In the figure showing us the phases that goes through the implementation of Monte Carlo search. Next slide, please. Neural networks. In this, AlphaGo game was developed mainly based on the MCTS. By training the neural networks using consistent producers that perform by step supervised learning policy that have been developed based on human actions. This learning process helps in development of neural networks, and these neural networks can be trained with possible policy networks, achieving the optimal outcome of game on its own. This AlphaGo game has become developed both with the policy value and the neural networks and MCTS. Next slide, please. Mm. There are different policy networks. We have like supervised learning of policy network, reinforcement learning, searching with policy and value networks. Uh, and the figure defines as training pipeline and architectures of the neural network. When the training neural networks, these the training are classified into four different types of learning, which plays a different role in developing the neural network, and that can help the Go game to achieve the accurate outcomes. Uh, Here we have supervised learning of policy networks. The policy network trained by random scenario actions under supervised learning has resulted to achieve the accuracy all 57% all the possible input data and permutations. The supervised learning is only defined by the pure board positions and the history of input variables. And the above formula is, here the formula is used, the percentage accuracy in the supervised learning of policy network. And reinforcement learning of policy network, when evaluated reinforcement learning of policy network, the accuracy of winning game is increased up to 80% when compared to supervised learning of policy network compared to the Go game, which has been developed using the sophisticated Monte Carlo search. And this policy had 85% accuracy of winning, whereas conventional game has 11 to 12% only against Pachi and Fugo, with this second total knowledge and possible input scenario defined previously. Here, when games are played between the current initiation and policy network and random select previous iterations of the policy network, results in a possible outcome that can use it to increase the chance of winning in future. And Rajesh will continue from here.
Thank you, Charita. Here I'm going to continue with the reinforcement learning of the value networks. Is linked to the previous stage of the learning of the processing to obtain the optimal value, which is an approximate the value, and the learning process is the mostly focused on the positions on the board, and the game are performed by the both the players of the by employing policies. And coming to the next slide. The searching with the policy and the value network, the values of the consequent possibilities of the edge cases will be coded for the conclusion of the simulation, which will help to the increasing of the GO games and accuracy percentage. It should be noted that the supervision the learning policy network of the outcomes of the stronger reinforcement of the learning policy network, because the human always choose the different moves to help with the help them to achieve with to achieve their goals. Wherever the RL policy network will also chooses a single solution that is derived from its process, which has a better value of the function than the supervisor learning. And here coming to the next slide. The masters of the game of without the human knowledge. The deep neural networks were also used to analyze the positions and set the moves in the in the tree search. By performing these type of self play, we are used to train the neural networks. Neural networks. We provided the method that is entirely based on the reinforcement learning with the human with no human data and supervision or the domain expertise other than the gaming rules, where we have learned the similar topics by our DICE class. And coming to the next topic. Here the alpha was the first program to achieve the superman of the performance in Go, and it became the first program to defeat the world champion in the game and the show as well. And coming to the recent advance in the artificial intelligence have been the made utilizing the supervisor learning system that have been the trained to the duplicate sections of the human experts in computer games like 3D virtual environments, and these systems have in the output perform the humans, which is can be having the having different types of and the important aspects. Mainly these can be the entirely by playing it the selfly and the reinforcement learning and the starting from the random play without these of the human interactions or the human data. And second one is the only the black and white stones are the board as the input features. And here the coming to the reinforcement learning in the AlphaGo, which is a deep neural network that maybe that takes the raw board representations of the position and in the history of the input and the output, the both are the moving towards the probabilities of the value. The main idea of these reinforcement value algorithm is to search for the operations repeatedly in iteration produces a novel reinforcement in the learning also approaches into the approaches to train the neural network into the different type of the gaming technology and also the games to play with the self to self among them. And coming to the self play and coming to the self play in the reinforcement learning. Here we are going to use that S1 to ST and again S2 itself. Now where you have the executed using the latest neural network in the each position that may be the most from the set according to the set of the properties and computed by the MCTS. By the MCTS is also the score to according to the rules of the game, and the finally are the calculated to the game to the game winners, or it may be sometimes it may be the game losers as per the intelligence. And coming to the neural network of the training in reinforcement learning. Next slide. The neural network is can be the trained by the self play and the reinforcement and the algorithm which are can be uses the MCTS to play the each move. The neural network takes the robot of the position and its output system with the passes through the main conventional layers from the parameters of the theta. parameters of the data and the outputs of the vector. And here we are the represented in the probability of the current player, which is can be the winning into the positions of the ST, as we can be shown in the above figure. The neural network are having the parameters which are can be applied to maximize the similarities, and then the policy vectors. And the policy vectors of the certain possibilities. Here we are going to minimize. Here we are going to have the maximum and then the minimum probabilities of the error between the predicted winners and the VD, and also the game winners and the game losers. And coming to the MCTS, the selections of the each simulation, maybe the travels by the trees by certain the edges with the highest action value of the Q, as we can shown in the figure, and in the upper case of the confidence and the consideration, the based on the U priority probability and the P, and then the P which we are going to show in the figures. And come into the backup, the mean of the all the evaluations V in the subtree and the below the actions is used to update the actions of the values Q. And coming to the play method, where the searches is can be the finished and the searches and the probabilities are the proportional to the N1. N1 they are going to be the refused, where the N is the set of the count of the each move from the root and the state, and then the temperature can be the controlling by the parameters. And coming to the imperial analysis of the AlphaGo generator training, is I will carry on to the Rajesh Kale.
Thanks, Charita, and thanks, Rajesh. So, my teammates like explained like mastering the game of Go like without the human knowledge and one with a deep neural analysis. So, well, like once we are done with everything, like we need to do some analysis of the research. So, this empirical analysis will explain like how this AlphaGo like zero training goes on. So basically, like this analysis explains about like 4.9 million games of self play was generated, and using like 1600 stimulations for each MCTS, which corresponds to approximately like 0.4 seconds, like things per move. This analysis like includes like three types of plotting that we did, that the author did. So first plotting is explains about the performance of the AlphaGo zero during the self-play reinforcement, and second is explaining about the prediction accuracy on the human professional moves, and third is like MSC. MSC means like mean squared error of the human professional game outcomes. So in the first plot, like when you go with the comparison, a similar player trained by the supervised learning from the human data. So here they are using some KGS data set, which is also shown in the figure, like where the plotting will happen. In this plotting, like the blue line will explain about the reinforcement learning, and the purple line will explain about the purple plotting will explain about the supervised learning, and the dotted plotting will explain about the AlphaGo Lee. And in the second plot, like in the second plot, like the accuracy of the neural network trained by the supervised learning is also shown, but the accuracy measures the percentage of the positions in which this neural network assigns the highest probability to the human move. Like whenever the human gave a move, like whenever he is going to shift with either black or white, like it will show the moves, like how the probability will be. So here also, like we have shown the two types of colored graphs, like color plottings. One is a reinforced learning and another is a supervised learning. And in the third one, it usually explains about the human errors. Like whenever we are doing some move, it will explain like why that move happened. So the MSC of the neural network trained by the supervised learning is also shown here. This MSA is between the actual outcome and the neural outcome. Like actual outcome in the sense like it will be calculated in the Z, and the value neural network, it will be calculated as a V. So those are like scaled by the factor of like 1/4 to the range from 0 to 1. And coming to the next slide, it will explain about the comparison of the neural networks that we already of the different architectures and the algorithms. So that the main intention of this comparison is like there are 4 neural networks were created in this particular research. Like these 4 neural networks are four neural networks are like the combination of the separate and the value networks. And one more is like combined policy and the value networks. So separate and the value networks comes under the AlphaGo Lee, and this combined policy and the value network it comes under the AlphaGo 0. And in this particular, they used the like fixed data set of the self gamings, like which is generated by the AlphaGo. So the result that was generated during this AlphaGo, like which will happen like after 72 hours of the self-play training. So this is partly due to the improved computational efficiency, but more importantly, the dual objective regulates the network to the common representation that supports multiple use cases. So this is one of the comparison they did for these all three architectures and the algorithms. So coming to the next slide, so what we learned, like we have learned some we gained some knowledge about like how AlphaGo will work and how they implemented the AlphaGo without the human knowledge. So coming to this slide will explain like AlphaGo is rapidly progressed from entire random moves towards some sophisticated which will explain some understanding of the Go concepts. And one more is like it is discovered as a remarkable level of the Go knowledge during itself when we are playing the self-play training process. This is also include not only the fundamental elements of the human Go knowledge, but also it will give some knowledge about the non-understanding strategies beyond the scope of the traditional Go. So there is a difference between like how the like old games will play, and now after implementing this one, like there will be changes there. So these are the things that we learned from this particular research. And coming to next slide, like they gave the one performance like when they compared like in the comparison, you will see like four different types of combinations of the neural networks, and here we can see the final response, like final response and the final performance. So this final performance is evaluated by the between the AlphaGo 0 and the AlphaGo fan. And in order to that, like we also played games against the strong existing program. So this will comes under the AlphaGo master. What is a AlphaGo master? AlphaGo master is a program which is based on the algorithm and the architecture present in this particular paper. Like the author already informed, and he already explained about this AlphaGo master as well. And in this evaluation, like all programs were allowed up to 5 seconds of the thinking time per move, but AlphaGo and AlphaGo 0 like they will take around like 4 seconds of the thinking time per minute. And AlphaGo fan and AlphaGo Lee will distributed over 176 GPUs and the 48 TPUs respectively. And the other also included some player which is basically like which won't be depend upon this raw neural network based on the AlphaGo 0. So this player is simply selected the move with a maximum probability. So here comes a few of the methods they used. One is a reinforcement learning. So basically the main definition for the reinforcement learning is it's a relation between the agent and the environment. So whenever the environment respond to the agent, whenever the agent observed the reward from the world or something environment, so he will react to that environment. So there is a cycle chain is going on. So this is called the reinforcement learning. And in that one, in the second example, in the second research paper, they used the concept called without human knowledge. So here comes the another thing called self-play reinforcement. So it is one of the important concepts that we learned here in this paper. And one is a search algorithms, and search algorithms, like we have learned a lot of search algorithms, and another is a supervised learning, and another is a AlphaGo versions. So here even like basically we have started the paper with the AlphaGo fan, and now we learned a lot of versions in the AlphaGo. And here comes the final conclusion of these two papers. So their findings, like whatever the other findings that are pure reinforcement learning strategy may be used to train like how to improve the superhuman levels even in the most difficult domains. Like it is possible to train the superhuman levels without human also. Like we already gave some examples on that one. And when we compare the trained on when you compare to training on a human expert data, a pure reinforcement learning strategy will take only a few additional hours to train and produce substantially superior axiomatic performance. So these are some conclusions that they come under from these both research papers. So these are some references that you took for this presentation. That's it for this presentation. Thank you.
Thank you.
Thank you.